जय हिंद स्टूडेंट्स, आप लोग कैसे हैं? आई होप यू ऑल आर स्टेइंग फिट, फाइन and you all are staying healthy and are in jovial mood. So students, in the previous lectures we have discussed about motion, types of motion and the forces that causes motion, isn't it? What we have discussed till now is regarding the force. Any external force acting on a body produces in that body an acceleration, or on the other hand, if a body is having accelerated motion, then we can safely say that some net external force must be acting on the body, isn't it? So students, let's discuss some of the common daily life observations, right? Suppose I simply leave this pen or this marker, then what will happen? It will simply fall downwards. It will get attracted towards the earth, isn't it? Similarly, when a ball or a stone is thrown in the vertically upward direction, then what happens? As the ball gains in height, its speed keeps on decreasing, and eventually at the highest point, it momentarily stops, that is, its velocity becomes zero, and thereafter it retraces its path and then comes downward. As it comes closer to the earth's surface, its speed keeps on increasing, and at the point when it strikes the earth's surface, the speed of that falling object is maximum. So what I mean to say is that if there is no force or there is no force of attraction, then what would have happened is, if we throw a stone or a body in the upward direction, then it would have never come back again. After gaining certain height, every object comes back towards the earth's surface. It suggests that earth attracts every object towards itself, isn't it? There are several other phenomena as well, like the motion of all the planets, including Earth, around the sun, the motion of moon around the Earth, the motion of all the artificial satellites in circular orbit around the Earth. So these all objects must be exerting force upon each other. Because students, we know whenever a body is moving along a circular path, then it is the case of accelerated motion. And just now I have told you, whenever a body is having accelerated motion, some net force must be acting on that body. So, revolution of earth around the sun or revolution of moon around the earth, it clearly suggests that there must be some force between the earth and the sun, between the earth and the moon. And student, that force is known as force of gravitation. So, in this chapter of gravitation, we'll be discussing about the gravitational force. Then we'll be discussing the universal law of gravitation. So, in this lecture, we'll be discussing about the force of gravitation and we'll discuss universal law of gravitation. Right, students? So, before we proceed, let's discuss some other examples as well. Right? Let me recapitulate whatever we have discussed. Suppose we take a string and we tie a stone or a ball on one end of this string, and the other end is held by a hand, and it is willed. So, its motion would be like this. This will be the motion of the ball or the ball, right? Suppose it is moving along this direction, right? It is willed in a circular path. Now what happens is, there is some force along the length of the string that is known as the tension in this string. That force enables this body to move along the circular path, right? And we are aware, students, whenever a body moves along a circular path, then its direction of motion changes continuously. Because at any instant, the direction of motion of the body while moving along a circular path is given by drawing a tangent at that particular point, isn't it? So, if the direction of motion changes continuously, it means that the velocity of the body is changing continuously. And due to this change in the velocity, the body is said to be in accelerated motion. And because the body is in accelerated motion, the body must be under the influence of some force. And that force, students, I have told you, that is known as centripetal force. It is known as centripetal force. So whenever a body moves along a circular path, then the force involved must be centripetal. Literal meaning of centripetal is center seeking. The literal meaning of centripetal is center seeking. Center seeking. And as you are aware, the direction of the centripetal force is always along the radius towards the center of the circular path. So it is a center seeking force, which is known as the centripetal force. So students, planets including Earth revolving around the Sun, Moon revolving around the Earth, or for that matter, all the artificial satellites which we launch from the Earth's surface, they keep on revolving around the Earth in a given particular circular orbit. Right? So, what is the force involved? Centripetal force. And student, this centripetal force is provided by the gravitational force of attraction between the two bodies under consideration. So basically, between Earth and Sun, it is the force of gravitation between the Earth and Sun that enables the Earth to revolve around the Sun in circular orbit. Between Earth and Moon, it is the gravitational force of attraction between the Earth and the Moon which provides the centripetal force so as to enable the Moon to revolve around the Earth in circular orbit. So, the centripetal force in these cases is provided by gravitational force of attraction. Clear, students? So, here I must also mention one very interesting fact. You must all be aware of it. It is said that Isaac Newton, while sitting under the tree, an apple fell on him, and later on he just analyzed the thing, and he concluded that the apple is getting attracted towards the earth. And he compared this situation with that of the moon-earth condition. He concluded that the moon must also get attracted towards the earth. I mean, the force between apple earth and the moon earth must be same. And that common force, students, that is known as the gravitational force. Earth attracts the apple towards itself, and as per Newton's third law, the apple must be attracting the earth towards itself. We are aware to each and every action there always exists equal and opposite reaction. The force, they always exist in pairs, equal and opposite pairs, isn't it? So let's consider the apple earth case. This is suppose the earth and this is the apple. Let us consider this. So these two are getting attracted. It gets attracted, body A and body B. This body A gets attracted towards the center of the earth. Body B will also get attracted towards the body A. That is, the force with which earth attracts the apple towards itself, the same force will be exerted by the apple on the earth towards itself. But students, can you tell me, why don't you see the earth to be moving towards the apple? We only observe the apple to be falling down towards the earth. Why not earth moving towards the apple? Can you state the reason? Yes, it can be justified using Newton's second law. Now, as a consequence of Newton's second law, we know that F is equal to mass into acceleration, isn't it? For an apple, acceleration would be equal to F by m. M is very, very small. M is very, very small as compared to the mass of the earth. So A is large. So a large acceleration will be experienced by the apple, due to which it falls towards the center of the earth. But students, on the other hand, in case of earth, the acceleration in the case of Earth would be same force is exerted divided by this m. It is the mass of the Earth, which is huge, which is very, very large. The mass of the Earth, students, it's about 6 into 10 raised to the power 24 kg. The mass of the Earth is about 6 into 10 raised to the power 24 kg, which is huge. While the mass of the apple, it's in grams, 50 gram, 100 gram, isn't it? While the mass of the Earth is of the order of 10 raised to the power 24 kg. It's huge. So, large mass. So, mass is very, very large. So, the acceleration produced on the Earth would be negligible. So, due to very large mass of the Earth as compared to that of the mass of an apple, a negligible acceleration is produced in the Earth. So, we don't see the Earth getting attracted or going towards the apple. Instead, because of the fact that the mass of the apple is negligible, so it experiences a very large acceleration, therefore, we see the apple falling towards the Earth. So, this is the reason, students. So, what I mean to say is that any two material bodies, they exert equal and opposite forces upon each other. Whatever force is exerted by the apple on the Earth, the same force is exerted by Earth on the apple. But the acceleration produced in both the bodies would be different because of their different masses. I hope you have understood the concept. So all the phenomena like revolution of all the planets including Earth around the Sun, revolution of satellites around the Earth, right? Then free fall of a body that is again towards the Earth. These all are because of the same force. And that force which we are talking about is force of gravitation. Right? So in this lecture we will discuss about this force only and how to mathematically measure this force. On what factors this force of gravitation depends upon. Clear, students? So let's start with the universal law of gravitation and then we'll discuss about this force in detail. So we'll discuss universal law of gravitation. Universal law of gravitation. This law was given by Newton's law of gravitation, right? Suppose these are the two material bodies. This is M1. Suppose its central mass is over here. The entire mass of this body may be assumed to be constant at this particular point. And there is another body B. This is body A and this is body B. Suppose its mass is constant at this particular point M2. Let us consider this to be the line joining the center of the two bodies, right? And let us consider the separation between the center of these two bodies is R. So what we have discussed is M1, M2 are the masses of the two bodies A and B, and R is the distance between the centers of these two bodies under consideration. Clear, students? So, universal law of gravitation states that every body in this universe attracts every other body with a force which is directly proportional to the product of masses of the two bodies. That is, it is directly proportional to M1 into M2, right? So the force is directly proportional to the product of the masses of the two bodies. And this force is inversely proportional to the square of the distance between the centers of the two bodies. This, students, it is known as inverse square law. It is known as inverse square law. Clear, students? So, I'll repeat this statement. How do you state universal law of gravitation? Universal law of gravitation states that every body in the universe attracts every other body with a force which is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between the centers of the two bodies. So this is known as universal law of gravitation. Every material body attracts every other body with this force, and it is always of attractive nature. Clear, students? This force is known as the force of gravitation. So combining these two, what you get is F is proportional to m1 m2 divided by r square. Now students, as you are aware, this is the proportionality sign. In order to eliminate this proportionality sign, we need to introduce some constant, and this constant is written as capital G. It is known as universal gravitational constant. So G m1 m2 divided by r square. This is the mathematical form of universal law of gravitation. G, students, as I have stated, it is the constant known as universal gravitational constant. It is known as universal gravitational constant. And its value is experimentally determined by a very sensitive balance by Cavendish, and its value is found to be 6.673 into 10 raised to power minus 11. Again repeat, G is constant. It is universal gravitational constant. Why universal? Because the value of this capital G, it remains constant everywhere, anywhere in the universe. It won't change. It will always remain constant. That is the reason why it is known as universal constant. Right? And its value is determined by a very sensitive balance, and its value was determined by Henry Cavendish. And its value is found to be 6.673 into 10 raised to minus 11. Now what about its units? Let's find out the units of G. So this statement can be modified in this particular manner. G is equal to F r square divided by m1 m2. So what will be the unit of G then? So unit of G is, and we are considering SI unit. Standard international unit of capital G is, SI unit of force is Newton. SI unit of distance, R is the distance, meter, so it will give us meter square. SI unit of mass is kg. This is also mass, which is kg. Kg into kg, it will give us kg square. So SI unit can be written as Newton meter square per kg square. So the SI unit of universal gravitational constant is Newton meter square per kg square. Is it clear, students? So once again I repeat, in this universe, every body attracts every other body with a force which is directly proportional to the product of masses of the two bodies under consideration, and it obeys inverse square law. That is, it is inversely proportional to the square of the distance between the centers of the two bodies under consideration. So combining these two, we get this. Capital G is the constant of proportionality, known as universal gravitational constant. Why it is known as universal constant? Because its value will remain same, no matter what the conditions are, no matter where the place is, its value will always remain constant. And its value is found to be 6.673 into 10 raised to minus 11. And what will be its units? Newton meter square per square kg. This is what we obtained. Newton meter square per square kg. So students, this is the mathematical form of universal law of gravitation. Clear, students? Okay, now regarding gravitational force, we will discuss some important properties. Gravitational force. Now, first important property is it is always of attractive nature, right? The two bodies will tend to attract each other, right? So its nature is attractive. The nature of the gravitational force is always attractive. Second, gravitational force, students, it is the weakest force in nature. Two students quite close to each other, there will exist a gravitational force between those two people or those two objects or those two students, but we never tend to feel it because gravitational force, it is the weakest force in nature. It becomes dominating only when we consider some celestial objects having huge masses. For terrestrial objects, that is for objects placed on the Earth's surface, between them the force of gravitation is negligible. But when we talk about heavenly bodies, between Earth, Sun, between Earth, Moon, the force of gravitation is huge. In that case, it plays a very vital role. Clear, students? So, these are the weakest forces in nature. Weakest force in nature. Third, gravitational force. It always forms action-reaction pair. Whatever force is exerted by body A on body B, the same force will be exerted by body B on body A. So, it forms action-reaction pair. It forms action-reaction pair. Okay, next property. Suppose these bodies, instead they are placed in air or vacuum, they are placed in some other medium having the same separation between them. Still, the gravitational force between them is found to be same. So what I mean to say is that the gravitational force between the two bodies is independent of the medium in which the two bodies are placed. So it is independent of the medium. It is independent of the medium. Next, as I have told you, it obeys inverse square law. It obeys inverse square law. And whenever a force obeys inverse square law, it is always of central nature. It's a central force. Central force means force acting along the line joining the center of the two bodies. It's not acting along this direction. The gravitational force will always act along this line which joins the center of the two bodies. And that is when the force is said to be a central force. So, it is a central force. It is a central force. Now, in higher classes, you will study that the gravitational interaction is due to the exchange of some field particle. So, the field particle in the case of gravitational force is graviton. Right? So, these are some of the important properties of gravitational force. Clear, students? And here I must again state why this law is known as universal law of gravitation. It is known as universal law of gravitation because this law is applicable for any two material bodies. Whether they are small bodies, whether they are big bodies, whether they are terrestrial bodies, whether they are celestial bodies or celestial objects. So whatever may be the type of the bodies, gravitational law is applicable between material bodies. Any two material bodies, this law is applicable. So that is why it is known as universal law of gravitation. Clear, students? So let's discuss some very, very simple numericals or rather conceptual questions based on this law. Okay, if the distance between the two bodies is made twice its original distance. That is, if new distance is made twice its original distance, then what will be the effect in the gravitational force? Then what will be the new force? Look, if r is replaced by 2r, then it will become 4r square. That is, it will become 1 by 4. So in that case, it will become 1 by 4 of the original force. So what I mean to say is that with the increase in the distance between the material bodies, the gravitational force will become weaker and weaker. And as the bodies are placed closer to each other, the gravitational force between them will increase. And how they vary with the distance? In this particular manner. It obeys inverse square law. So if the distance is made twice, it will become 1 by 4 times. If the distance between the two bodies is made thrice, the gravitational force will become 1 by 9 times. If the distance between the two bodies is increased to 4 times, then the force between them will get reduced to 1 by 16 times. Clear, students? While on the other hand, if the distance between the two bodies is halved, in place of r, write r by 2. So, in that case, the force will become 4 times stronger. Understood now? Okay. Let's discuss a very simple numerical so as to convince you that gravitational force indeed is a weakest force in nature. Between any two material bodies, terrestrial objects, the gravitational force is almost negligible. But as I told you, between celestial bodies, between heavenly bodies, gravitational force does play a huge role. Its magnitude is quite large in such a scenario, in case of celestial or heavenly bodies. But in case of terrestrial objects, it is negligible. Let's discuss this very fact with the help of a numerical. So we are considering two objects. Suppose one is of mass 50 kg and this is the second object. This is suppose of 40 kg placed at a distance of 1 meter. So here M1 is 50 kg, M2 is 40 kg, R is 1 meter. So we can easily find out the value of gravitational force acting within these two. These two bodies must be attracting each other, right? Let's try to find out the magnitude of that force. So force as per the universal law of gravitation is given by G, M1, M2 by R square. Let's substitute the value. What's the value of G? You need to remember this value, students. So it is 6.673 into 10 raised to minus 11. What's the mass of these two bodies? One is 50 and the other one is 40 kg. Divided by distance is 1. So what do you get? 6.673 into 10 raised to minus 11 into 5420. So 2 into 10 raised to 3. Divided by 1 square will give us 1. So that will give us into 10 raised to minus 8 Newton. If you solve it, 6.673 into 2, that will give us 13.346 into 10 raised to minus 11 into 10 raised to 3. So base being same, the exponent or power will get added up. Minus 11 plus 3 will give us minus 8. So students, it's minus 8. So it is 0.00000 something. So this force is negligible. This force is negligible. This is what theoretically I have stated, which has been mathematically verified. So the force between any two terrestrial objects placed on the Earth's surface, the force between two chairs, the force between two persons, the gravitational force between a bus and a car, all those forces are negligible. It is only when we consider the two material bodies to be celestial objects, then the gravitational force will be huge. Clear, students? So I hope you have understood this concept very well. So in this lecture, what we have discussed is the gravitational force, the properties of gravitational force, and obviously the statement of universal law of gravitation.